Hello, this is Derek Daly, and this is my R3 Summit video. Here is our completed microprocessor, and I will go over the structure. So, where my cursor is, this is the control area. Us, the human, or the user, acts as the control as we change the inputs for the clock, read and write. The clock allows for the operations to move forward when it pulses. The read and write control which kind of data is being put into the bus. The address input affects which piece of data is going into which uh, the address of the memory. We have our read only memory and our random access memory, as you can see. And then up here's our processor, which controls the flow of data, how we load it into our mini ALU, and then if we want it to go out into the data bus to store it. So now that we have that explained, let's multiply 10 by 6. So I'm going to put our 6 down here and our 10 up here. And first things first, we want to read this in, so we enable read. And I want 6 to be loaded up first, so we're going to put that in B. As we can see, it's B prime. For B it's prime here, so have that off. Enable. There we go. So all we need is a clock edge to store it in that register. There we go. And now we're going to switch the address back to 0, which correlates to our read-only memory 0 right here. I'm going to turn on this so we can get our A value loaded up here. And now we're going to multiply these together and then load it into our accumulator with a clock pulse. There we go. And we can go ahead and just turn everything off in the meantime, since we have our value stored here. And now we're going to put it in our data bus, and in order to get our RAM to hold this, we are going to do write, and we're just going to go to 7, and as you can see, the value should be stored in this one right here, the second our clock pulses. So there we go. Alright, there it is. And the data bus is this wire right here, which holds a value and connects to our memory. And pretty much that the data bus just essentially allows us to transfer data. Yeah, I mean, that's pretty much it. Buffers are really important, so we don't have data constantly being put into this data bus, which can only hold one value. And if we have multiple values put into this one wire, then obviously it wouldn't work, because that's not how it works. So data buses are important for that reason. And it's really helpful to have our microprocessor to only allow register changes at positive clock pulses, so we can it just allows us to control the flow of data. Obviously, if we didn't have that, then the registers would hold data not according to how we would want, which is, in this case, a positive clock pulse. And how many gates would be contained in the ALU? Well, let's find out. So here it is up here, but if we go in here, we have, let's see, we have our subtractor, adder, multiplier, 4 muxes, and our mini LB, which has 4 gates and 3 muxes. So to put into perspective, quite a lot of gates. This is very abstracted, and I'm kind of glad it is, because that's an atrocious amount of gates that otherwise we'd have to put in here, and it would just look like spaghetti. So I'm glad we have our hierarchical design for that exact reason. So that is my R3 Summit video. Thank you very much.